2010 Grade 9 Friar Math Contest. Following sequence of figures shows arrangement of square tiles. Figure 1, Figure 2, and so on. More figures can be drawn, each having one row of tiles more than the previous figure. This new bottom row is constructed using 2 tiles more than the number of tiles in the bottom row of the previous figure. The figure 4 is cut into 2 pieces as shown. Draw a rearrangement of these 2 pieces showing how they can be formed into a square having 16 tiles. Alright, so here's my first piece, here's my second piece, and I think you just take this guy and you just rotate it. So you just kind of rotate it so that it would fit like that. And let me just draw in those squares there. So basically what I did was I just took that piece and just rotated it and then put it like a puzzle so that it matches the other piece. And then as you can see, this is indeed a 4 by 4 square, which is 16 tiles. So I think that's all they're getting at there. Okay, determine the number of tiles in figure 5. Okay, so if you were looked at figure 1, 2, 3, 4, this is 1, this is 4, but instead of writing 4, I want to write it in terms of how many are in each row. So it's 1 and 3, so it's 1 plus 3. Here it's 1 plus 3 plus 5. And then here it's 1 plus 3 plus 5 plus 7. So I'm sure you can get sort of a understanding of how this is progressing. So figure 4, actually figure 5, that would just be 1 plus 3 plus 5 plus 7 plus 9. And I'm pretty sure that is what it would be. And the number of tiles, therefore, I guess I would have to add it up. It was 1 plus 3 plus 5 plus 7 plus 9. And that is 25. So that's part B. Part C asks, determine the number of tiles in the bottom row of figure 10. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now each figure, it increases. So for example, this was figure 1, this was figure 2, this was figure 3, this was figure 4, and this whole thing was figure 5. So 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Correct? So I guess the bottom row would be the last guy right there. So that's 19 would be the answer to this question. Yeah. And then the part D says, determine the difference between the total number of tiles in figure 11 and number of tiles in figure 9. Okay, so this was all the way up to figure 10, right? And then this one would be figure 11, would be 21. So figure 9 would be all these guys, because that's figure 9. And then figure 11 would be all of these. So if you take the difference, it would basically be the sum of all of these minus the sum from 1 to 17. So that would essentially leave you with just 19 and 21, which is 40. So you can write that out in more detail during this kind of an exam because it's long solutions. So I'm just kind of giving you the rundown, basic rundown. Determine the average of the following integers. All right, well, this is pretty straightforward. You add them all up, and then you divide by the number of integers, which in this case is 5. And of course, that will give you 73. So that's pretty straightforward. Part B, suppose that n to n plus 4 are 5 consecutive integers. Determine a simplified expression for the sum. All right, so I guess we're just adding it up. N plus 1 plus n plus 2 plus n plus 3 plus n plus 4. And when you add up these guys, you get 5n plus 10. And that's all they're asking there. Part 2 of part B. If the average of these 5 integers is an odd integer, explain why n must be an odd. Okay, so the sum was 5n plus 10, so the average will be divided by 5, so that's going to be n plus 2, right? Yeah. n plus 2. So they're saying that the average is an odd. So this n plus 2 is odd. And then they're saying explain why n must be odd. So n is 2 less than n plus 2. So if n plus 2 is odd, n is odd. Because if you take any odd number and subtract 2, you'll get an odd. So for example, 7 is odd, right? But if you take 2 away, it gives you 5, which is also odd. So that's basically how you would explain that one. Part C. 6 consecutive integers this time can be represented by n through n plus 5. Explain why the average of 6 consecutive integers is never an integer. All right. So the same kind of story, add them all up, n plus 1 plus n plus 2, and so on, all the way up until n plus 5. And then divide this time by 6. And when you do, you get 6n plus 15 over 6, which is n plus 15 over 6. Now, they're saying n is an integer, so the only way this would be an integer is if this was an integer, but 15 over 6 is obviously not an integer. So since n is an integer, n plus 15 over 6 is not an integer. So that's basically the explanation. And I'm pretty sure that would be sufficient. Number 3. Train 1 is traveling from Amville to Batten at a constant speed. Train 2 is traveling from Batten to Amville at a constant speed. Train 1 travels at 60 kilometers an hour and travels 2/3 of the distance from Batten in 9 hours. Determine the distance from Amville to Batten. All right. So speed is equal to distance over time. We'll probably use that formula several times in this question. And what are we trying to do here? For T1, let's make a little table with speed, distance, and time. Speed they gave me is 60. It's right there. Distance, that I don't know, but they do tell me that it's 2/3 of the distance to Batten. So if it starts here, it goes 2/3 of the distance to Batten. So let's make the full distance x. So it's 2/3 of x, whatever x is. And the time they told me is 9 hours. Okay, so I've got some information there. And I think I can just use this formula. So speed is equal to distance over time. So that means 60 would be equal to 2/3 x over 9. So 9 times 60, if I cross multiply, is 540, is equal to 2 over 3x. And therefore, cross multiply again, 540 times 3 over 2 is x. And that's going to be 270 times 3, 810. So 810 kilometers is the distance from Amville to Batten. Great. Okay, B. Train 2 travels 2/3 of the distance from Amville in 6 hours. How fast is this going? Okay, so same kind of story, I think, but this time train 2. So speed, distance, and time. The speed, that's what I'm trying to figure out. So, okay, I'll just call it S for now. Distance, well, it's 2/3 of the distance. So 2/3 of the distance, which is 810, and I believe that's 540. And then the time, they tell me 6 hours. Okay, so I'm going to use the same formula. Speed is equal to distance over time. So 540 over 9, and I believe, sorry, don't make that mistake. 540 over 6. I don't know where I got 9 from. Maybe I was thinking about the previous question. Anyhow, 540 over 6, and that's 90. And make sure you put in the units, kilometers per hour. Okay, so now we're down to C. Let's see here. What is C talking about? Train 2 started its trip 3.5 hours after Train 1. Both trains arrived at Cuford at 9 p.m. What time did Train 1 leave Amville? Okay, so Cuford is the town in the middle. This guy, okay. All right, so, okay. Let's just keep that in the field so we kind of know what we're talking about. So let's just make a little table. Train 1 and Train 2, speed, distance, and time. So Train 1, I believe we have concluded that, well, I think that was given to us, that it was 60, but 90 for Train 2. I think that's what we just got that. Okay. Distance. Okay, here. Let me think about this for a second. Distance. Well, using the formula speed is equal to distance over time, distance would be speed times time, right? So if I actually don't know the time, I think that's what we're trying to figure out, right? What time? Yeah, what time did the train? Okay, so we're concentrating on time. So I'm just going to let the time equal t since I don't know what the time is. So using this formula, distance would be speed times time, so it would just be 60t, like that. And for train 2, okay, that train 2 is a little bit different because train 2 started its trip 3.5 hours after train 1. So that means train 2's time is 3.5 hours less. Yeah. So this would actually be t minus 3.5. I just got to make sure I do that correctly, because if I don't, then it'll all get messed up. I'm pretty sure that's correct. And then the distance, using the same sort of formula right here, distance would be speed times time. So it'd be 90 times t minus 3.5. Yeah. Yeah, I'm pretty sure this is the correct setup. Okay. So now we can just move forward with a calculation. And the calculation is, what is the calculation actually? Well, let's go back and let's talk about this question. Train 2 is here initially, right? And then train 1 is here. And they both arrive at Cuford. Okay, I got it. So one's going this way, and the other one's going this way. So train 1 travels a certain distance, and train 2 travels a certain distance. But if you add their distances, it's the total distance, which we had calculated as 810 somewhere. Yeah, right here. Okay, I got it. Okay, so the distance for train 1, so I'll just write D1, plus the distance traveled by train 2 would be the total distance, which is 810. Okay. All right, so let's figure this out. So D1 is the 60t, and then D2 is the 90 times t minus 3.5, and that all equals 810. So hopefully this will give me my t. And let's calculate this. So we got 60t plus 90t minus, what's that, 3.5, so, oh boy, whatever that is, 315, I think. And then 810. So this is 150t, and that's going to be 1125. So t is going to be 7.5, I believe. So this is 7.5. Now, what did they want? They wanted, what time did train 1 leave Amville? What time did train 1 leave Amville? Okay, they arrive at 9 p.m., right? According to this guy right here. Yeah, that one. So so it would be 7.5 hours before 9. So 9 p.m. minus 7.5 hours, which is what, 1:30 p.m.? Yeah. Okay, so I guess that's the answer. There you go. Number 4, a palindrome is a positive integer that is the same when read forwards or backwards. For example, 3 palindromes are 7, 121, 773, 9377. Determine the number of palindromes less than 1,000. Okay, so less than 1,000, I'm going to break it up into 1-digit palindromes, 2-digit palindromes, and 3-digit palindromes, right? So the number of palindromes that are 1-digit are positive integers, so 1 through 9. So there's 9 of those guys. The number of palindromes that are 2-digit are like 1, 1, 2, 2, all the way up until 9, 9. And there's, of course, 9 of those guys. 3-digit palindromes is a little bit different because you've got 1-1, something like that. 2-2, something like that, dot, 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 all the way up until 9-9. And for each of these, this middle number can be anything from 0 to 9. So that's 10 choices. So for each of these, you got 10 choices. And since there's 9 of those guys, it'll be 9 times 10, which is 90. So you got to add this 9, and this 90, and when you do, it's 108. So 108 would be the answer for part A. Part B, let's see. Determine the number of palindromes with 7 digits. Ooh, okay. 7 digits. 1, 2, 3, 4, 5, 6, 7. All right. Okay, 7 digits. What do I do here? Well, a palindrome is of the form A, B, B, C, C, and D, right? That's sort of the way a palindrome works. So, well, the first digit can only be between 1 and 9. It can't be a 0 because if it was a 0, it would no longer be a 7-digit number. It would be a 6-digit number. So that means I've got 9 choices for the A. For the B, it can be anything from 0 to 9. So that's 10 choices. Similarly, 0 to 9 for C and 0 to 9 for the D. And then whatever goes in this A, that same thing would go here. Whatever goes there would go here. Whatever goes for the C would go here. So we've got 9 times 10 times 10 times 10. So that's 9,000, I believe. That's how many different choices we have, and therefore that's how many different 7-digit numbers we can create. That would be a palindrome. C. If the palindromes in part B are written in increasing order, determine the 2, 1, 2, 5 palindrome in the list. Okay. All right, oh boy. Well, the A can be between 1 and 9, right? So we're going to start off with the smallest one, which is 1. So 1, 2, 3, 4, 5, 6, 7. So the smallest palindromes will have a 1 where the A is. And then for the B, the C, and the D, we had 10 choices for the B, 10 choices for the C, and 10 choices for the D. So 10 times 10 times 10 is 1,000, right? So that means we have 1,000 that look like that, where the first and the last digits are 1. So these are the first 1,000 palindromes of our list of 9,000. The next, the second 1,000, so this would be the first to the 1,000th. This would be the 1,001 to the 2,000, I believe. And those would be the with 2s, where the A is. Like that. So this would still be a B, C, D. And then similarly, you'd have 10 choices for B, C, and D. And then now, what do they want? They want the 2125. 2125. So I got to keep going here. So the third 1,000 palindromes would be from 2001 to 3,000, right? So this is the category where I'm going to find that 2125. Let me just put that in brackets. That's the one I have to figure out. And it's going to start with a 3. And again, B, C, and D. B and C. Okay. So so far I've just figured out that I'm pretty confident that the first and the last are going to be 3s, but now I got to figure out the other numbers. Okay, so the B can be anything from 0 to 9. So the, let's see here. There's going to be 10 choices for this, 10 choices for that, so 100. So when I put something like 0 for B, like that, I'm going to be able to create 100 of those, because for C and D I've got 10 choices each. So this is going to be the next 100. So wait. Something went wrong here. Hold on. No, I think I'm fine. I'm fine. I kind of second guessed myself. This is going to be from 2001 to 2100. Yeah. This palindromes of that form, where C and D are some number. Yeah, I think I'm going in the right direction. Okay, but I got to get 2125, so I got to keep going. So from 2101 to 2200, that one, that's going to be the next B, which is 1. Yeah. Okay. I got it. Okay, so this is the I guess the range in which the 2125 lies. Okay, I got it. Okay, so I've gotten the fact that the first is going to be 3 and the second is going to be a 1. Okay. So now I've got to look at C. C is anywhere between 0 to 9, right? So 3, 1, if C is 0, then this would be the next 10 because there's 10 choices for D. So this would be 2101 to 2110, right? And then if this C is 1, then these would be the 2111 to 2120. And then therefore, if this is 2, if the C is 2, then it would be 2121 to 2130. And this is the range in which the 2125 lies. So now I get down to the nitty gritty, which is 2121, 2122, 2123, and then 2124, and then finally 2125. So the D for this guy would be 0, then 1, then 2, then 3, then 4. And if I fill in the other ones, it would be 3, 1, 2, 2, 1, 3. Is that right? 3, 1, 2, 4, 2, 1, 3. Yeah. Okay, so I hope you followed me. I had to sort of take it in different steps there to get to final answer. A little challenging for grade 9, I think, but not too bad. All right, the final one. Determine the number of 6-digit palindromes that are divisible by 91. The number of 6-digit palindromes, so 1, 2, 3, 4, 5, 6, that are divisible by 91. Ooh, all right. Okay, so this is going to be a bit challenging here. Okay, let's see what we can do. So again, we have A, B, B, C, and C. Okay, 6 digits, right? Okay. So for A, our choices are between 1 and 9. So we have 9 choices. For B, 0 to 9, 10 choices. And for C, 0 to 9, 10 choices. So if you multiply these, there's going to be 900 6-digit palindromes. Now we want to know, of those 900 6-digit palindromes, how many are divisible by 91? Okay, so I think what I'm going to do is first I'm going to write these out. Meaning, write it out as a number. So this is A plus 10B plus 100C plus 1000C plus 10,000B plus 100,000A. And when you add those up, you get 100,001A plus 10010B plus 1100C, I believe. Yeah. And then these all have 11 as a common divisor. So I factor out the 11. I get 9091A plus 910B plus 100C. Okay. So if this is divisible by 91, this whole thing has to be divisible by 91. But 11 is not divisible by 91, so this must be divisible by 91. Okay, so that's what we have to concentrate on. All right, so let's take that whole thing that must be divisible by 91, and let's work with that, and let's see what we get. So this is where the question is a little bit tricky. You got to do a little bit of fancy algebra here, which is quite challenging. You got to rearrange this a little bit to get something that has 91 as a factor, and then we can then concentrate on what's remaining. So how I'm going to do that is I'm going to first break up this A into that. And then the 910 I know is divisible by 91 because it's just 91 times 10. So I'm going to leave that alone. And then this 100 I'm going to break up into 91 plus 9. And I'm doing that on purpose. I'm just trying to get things that are divisible by 91. And when I do, I can now group up the guys that have 91 as a factor. This one has 91 as a factor. This one does. And this one does. So I group those together. And then whatever's left, I kind of just put it by its on the other side, basically, you know, kind of like leftovers. Okay, so this is divisible by 91. That's pretty obvious. And then when I factor out the 91, it's 100A plus 10B plus C. So that's pretty good. But then what I have left is this 9 times C minus A. Okay. So again, going back, we wanted this to be divisible by 91. Okay. Well, this is what it's equal to. Well, this is obviously divisible by 91. 91 times something. So therefore, this must be divisible by 91. So now 9 times C minus A must be divisible by 91. And remembering our parameters, that C was what? Anywhere between 0 and 9, and A was anywhere between 1 and 9, correct? Yeah. All right, so when I first thought about this, I thought, well, there's no way that's even possible, right? Because how are you going to get, you need at least 91. There's no way you can get 91. But then I thought, well, what if it's 0? I think 0 would work. And therefore, if C minus A is 0, then this would become 0, and then it would all work out. And is that possible? It is if C is equal to A. But that's pretty much what C minus A equals 0 means. And I think that's pretty much what would do it. C would have to be equal to A. So we have A and B and C, right? According to our original, our very first thing, we have 3 letters. And our parameters are that A is anywhere between 1 and 9, and C is between 0 and 9, and B is between 0 and 9. Now we want A equal to C. So that would mean we want a situation of 1, 1, 2, 2, 3, 3, dot, 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 all the way to 9, 9, right? But then for each of those, there's 10 choices for B. There's 10 choices here, 10 choices here, 10 choices here, dot, 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 10 choices here. So there's 9 scenarios where A is equal to C. And then from each of those scenarios, there's 10 choices for B. So the total would be 90. And that is pretty much the answer to the question that how many 6-digit numbers are divisible by 91.